Right, so we have graphing, sine, and cosine functions. We are going to do vertical transformations, amplitudes, and the periods. So we have our first function, f of x plus equals 3 plus sine of x. So in order to graph this function, this is going to be a vertical transformation. That means we're going to start with the graph of sine of x and move it up 3 places. So I'm going to go ahead and draw the graph of sine of x, so I'll be right back. So this is what your normal graph of sine of x is going to look like. So this is just f of x equals sine of x in blue. F of x equals sine of x. This is just your f of x equals sine of x function, your normal one. So as you can see, this our function without any transformations, anything done to it. We have an amplitude of 1. That means this function goes all the way to positive 1 and also all the way down to negative 1. This is negative 1, by the way, and this is positive 1. So that is our sine function, just sine of x, and we want 3 plus sine of x. So in order to graph 3 plus sine of x, we are going to vertically transform this up 3 places. So our new, since right here we have an amplitude of 1, that means we are going to have an amplitude of 1 again, but we're going to be up 3 places. So we're going to count 1, 2, 3. And this is where where we're going to graph our new function of sine of x. As you can see, sine of x, the function of sine of x has it crosses at it goes like that, and it ends at 2 pi, so 2 pi, and it crosses the x-axis at pi, and it pretty much has this high point right here at 1 at pi over 2, and has this low point here at negative 1 at 3 pi over 2. So that's just your standard sine function. So we are going to basically do the same thing we did here, but up 3 units. Again, we are going to have our amplitude of 1. That means this top part of sine is going to touch number 4 right there, and this bottom part of sine is going to touch number 2 right there, because it has an amplitude of 1. This is 1 and this is 1, henceforth an amplitude of 1. So I'm just going to go ahead and draw this function, and I'll be right back. So this is what we came up with. Again, shift the graph of sine, shift it up 3 units, 1, 2, 3, and this goes all the way to 4. This again crosses pi at our x-axis right here, crosses pi, goes down to 2, and then goes back up to 4. So that is, I changed this to the graph of g of x instead of f of x, so just so we don't get confused with the graph. So this our new function is g of x equals 3 plus sine of x. So that is how you graph number 1, f of x equals 3 plus sine of x. So let's go on to number 2. We have g of x equals negative sine of x. So again, we're just going to start with the normal graph of sine of x, and we see that we have a negative here. Again, it's going to have an amplitude of 1, and we have a negative here, so pretend there's a negative 1 over here, so it's an amplitude of 1, but it's a negative. That means it's going to be pretty much flipped on the x-axis. So we're going to go ahead and I'm going to go ahead and draw the normal sine of x function, the normal graph. So I'll be right back. And so this is your normal graph of the function of sine of x, and we have a negative 1 here. So what we're going to do is basically just flip this across the x-axis, kind of like mirroring it like a mirror. So we're gonna go ahead and do that right now, and then I'm gonna draw that in purple. So I'm going to draw the new graph of our g of x of negative sine of x. So again, we're just going to mirror it across the x-axis. I didn't really think purple was going to stand out that well. I should have used red, but I drew it in green. So in green we see that the graph of negative sine of x is basically just like this one, but mirrored across the x-axis, kind of like flipped. So that is how you draw that is how you graph the negative sine of x function. Again, amplitude of 1, and then just flip it across the x-axis, and yeah, that's how you do that one. Let's go to our third one, which is f of x equals 2 times cosine of x. So this is another trigonometric function. This is cosine instead of sine. We were working with sine. Now we're going to work with cosine. The cosine function looks a little different than the sine function. They're graphs. So we are going to basically draw what I'm going to do is I'm going to draw the normal cosine of x function without anything done to it, and then we're going to go ahead and apply what we want to do to it. So basically 2 times cosine of x, that's just going to basically stretch your graph by a factor of 2 vertically. So let's go ahead and do that. So this will be your graph g of x of cosine of x. This is just what the normal cosine of x function looks like without anything done to it. Again, we have the amplitude of 1. It goes down, crosses pi over 2 at the x-axis, has this point at this lowest point, -1 at pi, and then goes up, crosses the 3 pi over 2 point at the x-axis again, and then ends at 2 pi. So if you didn't already know, all of these sine and cosine functions, their period ends at 2 pi. So that means this will repeat over and over and over again for a period of 2 pi, which is from here to here. So yeah, now that we have our graph of the normal function of cosine, we see here that there's a 2 here. That means it's going to be stretched by a factor of 2. This means it's an amplitude of 2. So we're going to go all the way up to, this function is going to be stretched out all the way to positive 2 and all the way to negative 2. So we're going to go ahead and see what that looks like, and I'll be right back. So now we come back and see how we stretched out the original function of cosine of x all the way to an amplitude of 2 to get the function f of x equals 2 times cosine of x, just how we have here number 3. So again, amplitude of 2, same x-intercepts, and yeah, that's how you do number 3. That's how you do that one. Now let's go on to number 4, which it states g of x equals cosine of 4 of x. So g of x equals cosine of 4 of x. This one's a little bit different from the rest. So on this one, we're going to have to find the amplitude, and we're going to have to find its period before we can even graph it. So let's go ahead and find the amplitude. Pretend there's an invisible number 1 here. That means our amplitude is obviously going to be 1. Because we have a 2 here, our amplitude is 2. We have a negative 1. Actually, no, it doesn't matter. An amplitude is basically, it has to be a positive number. It cannot be a negative 1. And if it is a negative, then just take the absolute value of that, and that's your amplitude, because we cannot have negative amplitude. That doesn't make any sense. So we have a 1 here. We have a 1, and our amplitude is 1. If it was like this one, which is a negative, our amplitude is still 1, because pretend there's a negative 1 here, and our amplitude has to be positive. We cannot have negative height. So we have here g of x equals cosine of 4 of x. So let's go. So we already know our amplitude. The amplitude is equal to 1. And now let's find our period. So just how I was explaining before, a period is basically this whole thing right here. This is basically the function. Cosine of x has a period of 2 pi. That means after 2 pi, it's going to repeat over and over and over again for intervals of 2 pi. Same here in the negative side and in the positive side, over and over and over again. Same with cosine. Cosine has a period of 2 pi. Again, it's going to repeat over and over and over again for a period of 2 pi. Same thing here and there. So this one does not look like it's going to follow that rule, cosine 4 of x. So we're going to have to find its period by doing a little bit of division. So in order to do that, we already know that the original cosine of x function has a period of 2 pi. So in order to find this one's period, we're going to have to divide it by 4. So it's going to be 2 pi divided by 4. That is going to give us pi over 2, I believe. Pi over 2. So cosine of 4 of x, again, take the original period of the function, which is 2 pi, divided by 4, this constant multiple, and then you're going to get pi divided by 2. So that is going to be your period. That means that instead of 2 pi where's our cosine of x function? Instead of 2 pi, our function is going to end at pi over 2. So I'm going to head and draw like the graph, the x and y axis, so you can see what I'm talking about. Okay, so now this is what I'm talking about. So this is the x-axis that I'm talking about. Y-axis, we got the amplitude of 1. Again, 1 over here, negative 1 over there. That's your amplitude. So let's go ahead and see here. So since we established our period to be pi over 2, instead of us ending at 2 pi like we did on the other functions, on the other graphs, we're going to end at pi over 2. So pi over 2 divided by 2 is basically pi over 4. So we need that function because that's going to be where your this is going to be where your cosine function is going to be all the way at the bottom part of negative of this amplitude. So it's going to be right here. And then we have pi over 4 divided by 2. It's going to be pi over 8. This is where your cosine function is going to basically cross the x-axis, just so you can get down here to this point and go back up to 3 pi over 8, cross that, and end that pi over 2. So again, I got this by dividing pi over 2. We got that as the midpoint. I got this one by dividing pi over 4 by 2. I got pi over 8. And I got this point by adding pi over 8 to pi over 4. So pi over 4 plus pi over 8 is going to give me 3 pi over 8. That is why I put 3 pi over 8 here, because it's in these parts are increasing by increments of pi over 8. So pi over 8 plus pi over 8 is pi over 4. Pi over 4 plus pi over 8 is 3 pi over 8. And 3 pi over 8 plus pi over 8 is 2 pi. I mean 2 pi, pi over 2. So that is basically how this period is going to look like. So let's go ahead and graph the basically normal cosine function just with these new x values in the x-axis at the amplitude of 2. So I'll be back and let's go ahead and do that. So we already have the graph of g of x equals cosine of 4 of x. Again, you just find the period by dividing 2 pi over this constant multiple, and then just split this thing into 4, so we can have our x-intercepts and our midpoint, and then just again amplitude of 1, just draw the normal curve of cosine of x, and now you get g of x equals cosine 4 of x. So that's how you do number 4. Let's go ahead and move on to the last one, which is y equals negative sine 4 pi of x. So this one is going to be a little different, kind of the same as the last one, but a little different. So let's go ahead and solve this one. So we'll graph this one. Again, we're going to find our amplitude. So let's go ahead and find our amplitude. Amplitude. Our amplitude. Again, like I said, we cannot have negative amplitude. So this is going to be, you guessed it, an amplitude of 2. Because we're going to go all the way down to negative 2 and all the way up to positive 2. So that's what this means by amplitude. We can't really have a negative amplitude here. So it's going to be an amplitude of 2. Let's go ahead and find the period. Again, our period is, since we're looking at the sine function, the sine function has a normal period of 2 pi. The normal sine function has a normal period of 2 pi. Divided by what? What's the constant multiple here? It's 4 pi. 4 pi is the constant multiple here, so we're going to divide 2 pi by 4 pi. And that's going to give us 1 over 2, 1/2. So that's going to be our new period. Our period is going to be 1 over 2. So again, we're just going to go ahead and draw the x and y axis and then label it so that our period is 1 over 2. So I'm going to go ahead and do that right now. So this is going to be our axis labeled. This is, again, amplitude of 2, so it goes all the way up to positive 2 and all the way down to negative 2. So we have our period of 1/2. So 1/2 is going to be our endpoint, basically where our period ends. Again, 1/2 divided by 2 is 1 over 4. 1 over 4 divided by 2 is 1 over 8. And from then on, we're just increasing by increments of 1 over 8. So 1 over 8. 1 over 8 plus 1 over 8 is 1 over 4. 1 over 4 plus 1 over 8 is 3 over 8. And 3 over 8 plus 1 over 8 is 1 over 2. So 1/2. So now we have our basically our period set up. So we see that the normal sine function here goes like this black line right here goes like that. With but this one's asking for an amplitude of 2, so it's gonna increase by an amplitude of 2. Again, we already found our period of 1/2, so our period is gonna be 1/2. So but we have here that it's a negative 2 sine of 4 pi x. So negative, again, just how we did in this example, we're going to reflect it across the x-axis. That is going to be how your negative sine function is going to look like. So right here, we are going to, this is our normal sine function, right? It goes something like that, like that. But in this case, we're going to reflect it across the x-axis. So it will look something like this. Again, make sure you cross your midpoint and end at uh, 1/2. So we're going to go ahead and do that right now. So this is how it's going to look like. This is going to be y equals negative 2 sine 4 pi of x. That's going to be your graph again, because we have a negative right here. That means it's going to get flipped. It's going to get reflected across the x-axis here. Again, if this wasn't a negative, it's going to be like that. Okay, it's going to be like that. So again, negative reflected across the x-axis. We got a 2, which is amplitude of 2, stretches all the way up to positive 2, and then all the way down to negative 2. We have our period of 1/2 goes all the way to 1/2, ends at 1/2. So that's basically it on this part of graphing sine and cosine functions, basically vertical transformations, amplitude and period. That's all I'm going to talk about today. So these are just some basic examples, and yeah, that's it.